So I've got this problem with my van. I fitted air conditioning and a 60 amp DC to DC battery charger, but because it's like an old school diesel engine with a Bosch VE fuel pump, it can't adjust the idle. So when I turn these devices on, the idle just drops lower and lower and lower. So this engine's supposed to run at about 900, so there it is running pretty happily at 900. Let's turn the air conditioning on. That brings us to 850. Let's put the DC battery charger on. That's taken us to 713. So it's quite a drop. Now you may be thinking, so what? It doesn't matter. It kind of does, because if I'm in the south of France and it's like 40 degrees centigrade, the oil will get really hot. As a result, it gets thinner, like the viscosity reduces. So when the idle is low like that and the oil is hot, the oil pressure will drop to worryingly low values like 8 psi, 9 psi, 10 psi at idle, which is potentially damaging to the engine. So I've got to do something. So I've come up with a pretty crazy way of fixing this. Let me show you my plan.
This is an idle air control valve, which is used on loads of cars. It adjusts how much air is flowing into the engine during idle. But what's interesting about this is it's actually just a 4-wire stepper motor with a worm gear that allows it to move linearly. So my plan is to use this to adjust the idle stop on my Bosch VE pump. All I need are 4 parts. The stepper motor, a 6-pin momentary switch, a capacitor, and a DC to AC converter. Now this isn't the way you're supposed to run a stepper motor, but it's the simplest, and it means I don't need a driver or an Arduino. Basically, you take each of the 12-volt AC phase wires and connect them to A1 and B2 on the stepper motor. Then take A2 and B1 and connect them together and add a bipolar capacitor in series. By using a switch, you can send either of the AC phase wires to this inner end of the windings. This will set the direction of the motor. The capacitor adds a 90-degree phase shift, which allows the 2 coils to run sequentially, moving the motor. Now, to be honest, I don't fully get how this actually works, and there's not much clear info online, so I'll leave it up to the comments for a more accurate explanation. Now, there's 2 switches on that diagram, but I'm using a DP-DT switch, which can control 2 circuits simultaneously. So it switches on the DC converter and selects the direction of the AC all at the same time. Right, so this is all finished and wired up. It looks a little bit janky and scary. I don't know if it's all going to blow up. So let's give it a go. It worked. Can't believe that just works like instantly. That wasn't meant to happen. Okay, right. It feels like I've broken it now. Yep. How have I managed to break it already? Oh, you know what? It's not broken, it's just jittery. So I think the 1000 microfarad capacitor I'm using is too big. So I've ordered some 10 microfarad capacitors to see if it works any better. So I just kept adding these in parallel until it stopped being jittery. I've got 8 in there at the moment. Look what it's like. And it's quite strong. I can like hold it back. Right, so I've got myself this Chungus thing, because this is a DC capacitor, whereas this is an AC or a run capacitor. That's pretty good. It doesn't look like it's wobbling about too much. I'm happy with that. It's pretty strong. I can stop it, but it's pretty strong. But I'm going to hold it down still. Oh yeah, no problem. Now I know this capacitor is ridiculously big, but I can't find a low voltage bipolar capacitor, so this is the best one I could find. This is where the motor needs to sit. I'm going to have to make a bracket to hold it in the right place. So it doesn't actually work, but don't panic.
A little bit of a quirk of this is it won't work on its own. I have to just give it a little bit of gas to overcome the spring pressure. So let's do it. That's a couple of presses. We've got that up to 1,000 now. And it's holding. Oh, that's so good. Listen to it dropped. I'm well happy with that. I'm happy. It's a shame you have to press the gas, but maybe it's a bit of a security feature. You can't just like accidentally press that and increase the RPM to some crazy high amount. Now you may be wondering why I've done it this way in particular, because you know there are easy ways to do it. For example, here I have a linear actuator, and you could argue that this is a better way to do it. It's less complicated, more powerful. You know, this thing has more torque, and it wouldn't need the silly box with capacitors in and stuff. It would just run directly from that 6-way switch. So yeah, you could argue that this is a better solution. The reason why I didn't do this first is because that idle air control valve is designed for an engine bay. It's designed for the heat and the vibration and the oil and the drips of water and all the kind of nonsense that happens in an engine bay. Whereas this is just plastic, built in China, is not designed for that environment. So I'm not sure this would last very long, whereas that idle air control valve, if I can make it work, will last for years, because that's its habitat, you know, an engine bay. So, you know, that's why I tried it. Now, if that doesn't work, I will probably stick with this. So I'm going to keep testing, and I'll probably update in future. Thanks for watching. Hope it's been interesting or useful, maybe. Do drop me a comment if you liked it, or even if you didn't like it. It's just good to know what people think. If anyone knows what that capacitor is doing in that circuit and can explain it better than what I've done, I'd love to know anyway. So yeah, thanks for watching.